Hello children. In the last video, we have discussed about the laws of refraction. We have stated the two statements related with the laws of refraction and we defined a new constant called as refractive index. Now today we are going to see this refractive index concept in a detailed manner. Okay, so in the last video we have explained that whenever you have two mediums, the refractive index of the second medium with respect to first medium is defined as the ratio of sine of the angle of incidence in the first medium to the sine of the angle of refraction in the second medium. Now this is the case when you have a pair of media. Now I haven't mentioned what is the importance of this refractive index. I haven't mentioned what is the importance. Now the importance of this refractive index concept is how much bending can happen or how much change in direction is happening to the ray of light can be explained using the concept of refractive index. You will understand this in a detailed manner whenever we see or whenever we solve the problems related with refractive index. So what you have to remember here is refractive index will help you to identify how much change in direction is happening when you are provided with a pair of medium. And another important point you have to remember here is since it's the ratio of two identical quantities, to ratio of the sine of the angle of incidence to sine of the angle of refraction, you could see it here. Since they are identical quantities, it doesn't have any kind of unit. So refractive index does not have any unit. Okay, no units will be provided for this refractive index. It's just a number. This is another important point you have to remember. So study the definition of refractive index, study the mathematical expression for refractive index, understand that refractive index gives you how much change in direction happens for a light in a given pair of media. And also remember refractive index doesn't have any kind of unit. Okay. Now the next topic we have to discuss is absolute refractive index. Absolute refractive index is also refractive index only, but the basic difference is this refractive index term is basically used when you have a single medium. You don't have a pair of medium, only one medium is given in the question. Then we will be using the concept of absolute refractive index. Now absolute refractive index of a medium is defined as the ratio of speed of light in vacuum to the speed of light in medium. Okay, the absolute refractive index is defined as the ratio of speed of light in vacuum to the speed of light in medium. Now two important points you have to remember here is the speed of light in vacuum or air is maximum and the value of that speed is also discussed in the first video, that is 3 into 10 raised to 8 meter per second. And one more important point we have mentioned is the speed of light in medium is always less than 3 into 10 raised to 8 meter per second. Now the representation for speed of light in vacuum is C. It is given here. Speed of light in vacuum or air is represented by C. And the speed of light in medium is represented by V. And always you have to remember your V will always be less than C. Since your V is always less than C, your absolute refractive index for any transparent medium will be greater than 1. So once they ask this question, why do you say that the absolute refractive index is always greater than 1? This is the reasoning you have to provide. The velocity of light in any medium is less than the velocity of light in air or vacuum. So if you take the ratio of C by V, then the refractive index value will always be greater than 1. Okay. So whenever you have one single medium, you will use the concept of absolute refractive index. When you have a pair of medium, we can use the concept of refractive index of the second medium with respect to refractive index of the first medium, otherwise called as relative refractive index. I'll explain this in detail